Hello everyone, I am Masood Ibn Abdul Wahid. Today in this video we are going to discuss about Thevenin's theorem. We are going to discuss about the statement of Thevenin's theorem, and after that we are going to take a sample problem. We are going to know how to solve it, and we will take some university questions for our actual solution. So as every one of you know that Thevenin's theorem states that any linear circuit with the two terminals can be replaced by an equivalent circuit consisting of a voltage source VTH in series with a resistance of RTH, where VTH is the Thevenin equivalent voltage and RTH is the Thevenin's equivalent resistance. So the same statement is represented to you here in terms of pictorial diagram. So this is the network. It may be having multiple sources, multiple voltage source, multiple current source. It may be big in size and it may be complex in terms of connections, but that complicated network with the output terminals A and B can be replaced or converted into a simple network, very simple network, which is having a voltage source in series with a resistor. So if we have any element between A and B, we can connect that at the end and we can easily find the current through the element or the voltage across the element or the power drawn by the element. Like that, anything we can calculate from this simplified network. So this simplification is done by Thevenin's theorem. So how to find VTH and RTH? That is represented to you in these diagrams. So VTH will be found by open circuiting the output points. So for this network, we have marked A and B to be the output terminals. We have to open circuit this load resistance and we need to find the voltage, which is called as Thevenin equivalent voltage. In the similar way, we have to turn off all the sources in the given network and we have to look back into the circuit to find RTH, which is Thevenin equivalent resistance. So the words turn off means if the network is consisting of voltage sources, we have to short circuit those, and if the network is having a current source, then we have to open circuit that. So this is what the explanation about the Thevenin theorem statements and the procedures to be followed to solve a network using Thevenin theorem. So now let us assume that this is the given network. Here they have mentioned the load current is flowing through 5 ohm resistance. That means this is the load resistance they have considered. If we want to find the load current IL using Thevenin theorem, first of all what we have to do is we have to convert this network into a Thevenin equivalent network, which is here. So now to find VTH, we have to redraw the network by open circuiting the load element. So here it is resistance. So we have open circuited the load resistance and we have marked the points A and B here. So now we are in need of finding the VTH, which is nothing but the voltage across the open circuited points, namely A and B. By doing so, you will find VTH. The only remaining thing in the Thevenin equivalent circuit is RTH. You need to find RTH. So to find the RTH, you need to redraw the given circuit by turning off all the sources. As in the given network there is only one battery, 4 volt, we have to short circuit that. If in case any current source is given, then we have to open circuit that to find RTH. So in our case, so there is only one battery voltage source. So we have short circuited that. Now we have to look back from the output terminal into the circuit as indicated to you here. So this is why the Thevenin equivalent resistance is also called as look back resistance. So this is how you have to use the Thevenin theorem to solve a particular network. Let us do the solution for the considered network. So let us assume that the given problem is in the circuit shown below, find the current IL using Thevenin theorem. So by the word Thevenin theorem, what we have to do is, first of all, we have to convert this given network into a Thevenin equivalent network. So before that, as they have marked the current IL in this branch, we will consider the 5 ohm resistance to be the load resistance. And if 5 ohm is the load resistance, then the output points will be here. Now to find the current using Thevenin theorem, we need to find the Thevenin equivalent circuit of the given network, which is this one again. So VTH, RTH, and these two are the load points, and this is where the load resistance is connected. So in the Thevenin equivalent circuit, we need to find VTH value and RTH value. To find the VTH, we need to redraw the circuit by removing the load resistance. Now the VTH will be the voltage across the open circuited points A and B. So the open circuit voltage VOC, which is nothing but VTH, Thevenin equivalent voltage. The voltage between the points A and B will be equal to the voltage across the 4 ohm resistance. Now to find the VTH, you need to find V4 ohm. So by applying Ohm's law, V is equal to I into R. So V4 ohm is equal to I4 ohm multiply R, which is 4. So now we need to find the current through the 4 ohm resistance, which is this one. So to find the current through 4 ohm resistance, I is equal to V divided by R. So V is nothing but the battery voltage 4, and R equivalent is the equivalent resistance between the two resistors, which is 3 ohm and 4 ohm. So to find the equivalent resistance, we need to find whether it is connected in series or parallel. Assume a current in the 3 ohm branch. So this is the current in the 3 ohm branch. So it will come up to this point. So after this point, if you look into this side, since it is an open circuited path, there will be no current in this way. All the current through the 3 ohm resistor will be directed to the 4 ohm resistor. So here we conclude that the current through the 3 ohm resistance and 4 ohm resistance are equal. Say that these two are connected in a series circuit. The equivalent resistance is the addition of given element. The voltage V is 4 ohm and the equivalent resistance between these two is 3 plus 4, which is written here, and if you manipulate it, it will be 0.571 amps. So you have to substitute this I4 ohm in this place to get the V4 ohm, nothing but VTH. By doing so, you will end up VTH to be 2.284 volt. So far we have calculated what is the value of Thevenin equivalent voltage VTH. So to find RTH, as we discussed before, to find RTH we need to redraw the circuit by turning off all the sources as done here. In the given circuit there was only one battery, so we have short circuited that, and now we have to look from the back side. So that is why it is also meant as look back resistance. So when you look from this side, you need to find what is the connection between the 3 ohm and 4 ohm. Assume a current which is starting from A flowing towards the network. So up to this point the current will be same. After this point, since there are two resistances, the current will get diverted into two parts. One through the 3 ohm resistance, another through the 4 ohm resistance. So now we can say that these two branches are connected in parallel. For a parallel connected network, 1 by RTH is equal to 1 by 3 plus 1 by 4. For which RTH you can write it to be 4 multiply 3 divided by 4 plus 3, and you can calculate it to be 1.714 ohm. So now we have calculated both the values VTH and RTH, and you can apply these two values into the Thevenin equivalent circuit. By doing so, the current IL, you can write it to be I is equal to V by R. Here the voltage is VTH and the resistances are of two values. One is RTH and another is RL. Both are connected in series. So you can have an equation like this. IL is equal to VTH divided by RTH plus RL. Now all the values you have already calculated, and you can substitute the values. You can compute the IL value to be 0.34 amps. So this is how you have to use the Thevenin theorem to solve any particular electric network. So now we have finished the solution of this sample network. As usual, we will go into the Proteus. I have opened the Proteus software and I have plotted the given circuit with an ammeter inserted in the 5 ohm branch. Now when you start the simulation, you can read the current to be 0.34 amps, which is correlated with our manual calculation. So this problem we have solved. Now as I said, we will take one Anna University question paper problem which is given to you here. Determine the Thevenin's equivalent circuit across AB for the circuit shown. So the circuit is given to you here and they have marked the points A and B to be here. So we should take these two as the output terminals and we need to determine the Thevenin equivalent circuit, which is nothing but this one. So to find the VTH, let us assume a loop current in the available loop. There is only one loop, so there will be only one current. So we need to find the current I. To find the current I, there are many methods available. So let me use the mesh analysis. So in mesh analysis, maybe you remember, you need to write the loop direction and you have to consider the assumed current direction and we have to form a voltage equation. From that equation, you need to find the required current. So that is what I am going to do now. To start that, let me name the nodes available. So as it is already mentioned, the point A to be here. So let me assume this same point as A and this same point as B. So with the two other nodes, one here C and another here D. So to use the mesh analysis, we need to write the loop direction. So for this circuit, let us travel in this given loop C, A, D, B, C. I am starting from C and from C, A, D, B, C. So once again I am saying wherever we are starting, we have to close up to that point. Then only it is considered to be a loop. Then only the current will be closing and then only the solution will be complete. Now, so when you travel from C to A, there is a resistance, and since the current direction and the loop travel direction are same, so the voltage drop will happen in the 10 ohm resistor, which is notated as minus 10I. And when you travel from A to D, there is a 5 ohm resistance. Again, the loop direction and the travel direction are same. Here also a voltage drop will happen for minus 5I. And when you travel from D to B, there is a battery, and according to the assumed current direction, internally inside the battery, the current is flowing from plus to minus. So it is a potential drop. So you will write minus 25. And when you travel from B to C, there is a 50 volt battery, and according to the assumed current direction, internally into the 50 volt battery, the current is going from negative to positive polarity. So it is potential rise. So it will be written as plus 50. And we have closed the loop equal to 0. Rearranging the terms, you will have 15I is equal to 25, from which you can write the I value to be 25 divided by 15, which you can compute it to be 1.667 amp. This is the current which is flowing through the considered loop. Now we need to find the voltage across the points A and B. For that, if you logically think, the voltage available at this point will be equal to the voltage supplied from this battery minus the voltage drop in this 10 ohm. So the remaining voltage will be available here as VA. The potential difference is nothing but VAB. So the voltage between the open circuited points VOC is equal to the voltage supplied by the battery minus the voltage drop in this 10 ohm resistor. So that will be the VOC, or it is also called as VTH. So as we have already calculated what is I, substitute the value of I here, 50 minus 10 times 1.667. So which you can calculate it to be VTH is 33.33 volt. So far we have calculated what is the value of VTH in the Thevenin equivalent circuit. Now we need to find the value of RTH. To find RTH, we need to turn off all the sources in the given network. As we have two batteries in the given network, both the batteries we need to short circuit and we have to redraw the circuit. If you redraw, the network will be this one. And you need to look from the output side. So this is RTH. We need to look from across this A and B points and we have to calculate what is RTH. To find RTH, first of all, we need to know what is the connection between the 10 ohm and 5 ohm resistance. For knowing about the connection, let us supply a current from the node A like this. As there are two paths available, the current will divide into two parts. Once the current is dividing across branches, then those branches are meant to be connected in parallel. So if you apply the equivalent resistance for the parallel network in this, when you apply the equation for equivalent resistance in a parallel network, 1 by RTH is equal to 1 by 10 plus 1 by 5, and RTH will be 10 times 5 divided by 10 plus 5, which you can calculate it to be 3.33 ohm. So once you find VTH and RTH, then you can draw the equivalent circuit and you can mention the VTH and RTH in the equivalent network as shown to you here. For the given question, we have discussed and provided the solution. So far in this video, we have discussed about the Thevenin's theorem statement, and we have discussed about the methods of finding VTH and RTH, and we have discussed what is meant by VTH and RTH, and we have solved the sample problem, and we have took one anonymous question paper problem and we have solved. As this is the first class, I took two simple problems. In the next video, I will take some complicated problem and we will discuss about the solution for those network using Thevenin theorem. So thanks for watching. Hope the video was useful to you. We will meet in the next video with two complicated problems from an NIST question paper related to Thevenin theorem. Until then, I am Masood Ibn Abdul Wahid signing off.